Procedure to solve the root locus problem we shall discuss. So first step, what you need to solve is get the general information about the number of open loop ports and number of branches, etc. from the G of S, H of S. These are the general steps to solve the problem of root locus. So second step, what you need to draw the pole zero plot, identify the section of real axis for the existence of the root locus, and predict minimum number of breakaway points by using a general predictions. So, and the step 3 is the calculate angle of asymptotes, and step 4 is the determine the centroid. Sketch a separate sketch for step 3 and step 4, and step 5 calculate the breakaway and break-in points. If breakaway points are complex conjugates, then use angle condition to check them for their validity as a breakaway points. Step 6, calculate the intersection points of the root locus with imaginary axis. And step 7, calculate the angle of departure or arrivals if applicable. And step 8 is the combine step 1 and 7 and draw the final sketch of the root locus. Step 9 is the predict the stability and performance of the given system by using the root locus. Now we shall go with the problem. So first step 1, poles. So 3 poles are there. S equals to 0, S equals to -3, S equals to -5. So there are 3 poles and Z value is here. Zeros are 0 here. So number of branches equals to P minus Z. N equals to P minus Z also. If you do 3 branches, you'll get. So 3 branches approaching to infinity. Starting points are 0, -3, -5. But the terminating points are infinity. Step 2, section of real axis. So one breakaway point exists between that is 0 and -3. How we can say that is one breakaway point exists between 0 and -3? So if you hold hand from here, okay. So only the addition of zeros and the poles. So 1, this is 1 and 2. So this is a odd even number. So no root locus exists from -5 to -3. Okay. Next step. From here, okay. If we start from here, so there is only one root. There is only one pole. So from -3 to 0, there is a root locus exist and also one breakaway point exists. Okay. So like this, we will find the breakaway point, and the NRL means no root locus and RL means root locus exists. So if it is odd number, that is how we will say that it is odd or even number. So if addition of zeros and also poles, okay. So if we hold hands at the -5, 1, 2, so 2 poles are there, so it is a even number. We can no root locus exist from -5 to -3. So if you hold hand at here, so there is only one number, that is an odd number. So root locus exists from -3 to 0. Like this, we need to find out. Okay. Next is step 3. Angle of asymptotes. So number of branches is here 3, right? Number of branches are 3. So 3 asymptotes you need to find, that is θ1, θ2, θ3. So θ1, what is the formula for theta? 2q plus 1 into 180 degree minus p minus z. Q equals to 0, 1, 2. Okay. So substitute the value of q and get the value of θ1, θ2, θ3. Next, find out the value of centroid. After solving step 3, angle of asymptotes, that is theta 1, theta 2, theta 3. So for theta 1, you need to substitute q value 0. And for theta 2, you need to substitute q value as 1. And for theta 3, you need to substitute q value as 2. So after finding the angle of asymptotes, you need to find out the centroid. So centroid formula is summation of real poles of, that is open loop poles, minus real part of open loop zeros divided by p minus z. So from this question, they have not given zeros. So they have given the only poles. 0, minus 3, minus 5, minus 0 divided by p minus z value is 3. So what value you will get? Minus 2.667. This is the value of centroid. After finding the value of centroid, the step 5, you need to find out the breakaway point. That is 1 plus g of s into h of s equals to. So in the question, they have given that g of s, h of s equation k divided by s into s plus 3, s plus 5 equals to 0, right? And this is what g of s, h of s value they have given. So after taking LCM, so if you take LCM, this will come to the numerator. So after solving that, s to the power of 3 plus 8 s to the power of 2 plus 15s plus k equals to 0, you will get. So k equals to minus s to the power of 3 minus 8 s to the power of 2 minus 15s. So if you differentiate with respect to s, what you will get? The equation minus 3s square minus 16s minus 15 equals to 0. So from this, find out the roots of this equation. So what you will get? S equals to minus 1.2137 minus 4.119. So when you substitute the value s equals to minus 1.2137 in this equation, so k value you are getting the positive value, then it is a valid breakaway point. If you get the negative value of k, if you substitute minus 4.119 in the k equation, that is what we have written before, right? K equals to, so this equation 1, in this equation, if we substitute as minus 4.119 instead of yes, so you will get the value is k value, you are getting the negative value, so it is an invalid. K value, you should get the positive value, then only it is a valid breakaway point. So here k equals to 10.287 at a breakaway point. Next step 6 is the intersection with imaginary axis. So here intersection with imaginary axis means 1 plus g of s h of s, what we got the equation. Same equation you need to write and you need to apply the RH method here. Intersection with imaginary axis, that is the step 6. So here you need to apply the RH method. First step you need to find out the poles, and next second step you need to find out where breakaway point will come and where root locus exists. That is the step 2. And in step 3 you need to find out the angle of asymptotes. Okay. In step 3, you need to find out the angle of asymptote. Step 4, centroid you need to find out. And in step 5, breakaway point. And step 6, intersection with the imaginary axis. That is RH method. So in last videos also we have discussed regarding the RH method, right? So this is a A0 value and this is a A2 value. This is a A0 and here this is a A2 value. And the A1 value is 8 and A4 value is K. A0, A1, A2, A3 value is K. So next step for s to the power of 1, that is 8 into 15 minus K divided by 8. Okay. So 120 minus K divided by 8. Next for s to the power of 0, this is a A3 value, we need to write K. Here for K margin, that is 120 minus K equals to 0. K margin equals to 180. So A of S equals to 8S square plus K equals to 0. So for S to the power of 2 equals to what you will get is minus 120 divided by, here we want the roots, okay, root of this, we need to find out the S, okay. So you, from this equation we cannot find out. So before that equation you take A of S equals to 8S square plus K equals to 0. You know the value of K, that you substitute. So S square equals to minus 120 divided by 8. So S value is plus or minus j 3.873 value you'll get. And here the roots are no complex. When you see, they have given s plus 3, s plus 5 in the denominator. So s equals to 0, s equals to minus 3, s equals to minus 5, you will get no complex roots are there. So no need of angle of departure, no complex poles are zeros, hence not required. Step 7 is not required. So you can observe here what is the step 7. Okay. Calculate the angle of departure or arrival if applicable. That is the step 7. So draw the root locus as shown in the figure. That is zeta equals to 0.6. The damping they have given 0.6. Draw the line at angle theta equals to cos inverse of. So we want theta value. So theta equals to cos inverse of zeta. You will get the value is theta 53.13 degrees. That is the measure with respect to negative real axis. So it intersects root locus at point minus 1 plus j 1.25. Closed loop dominant poles for zeta 0.6. That is S equals to what we got is minus 1 plus or minus j 1.25. These values, okay. So minus 1 plus j 1.25, and closed loop dominant poles for zeta 0.6 are S equals to minus 1 plus or minus j 1.25. So here what we can write, S plus 1 plus j 1.25, S plus 1 minus j 1.25 equals to 0. So when you compare the with the standard equation, S square plus 2 zeta omega ns plus omega n square. So what value you'll get the omega n equals to 1.6 radians per second, and K for zeta equals to 0.6 they have given in the question. So is to be obtained from the magnitude condition. So what is the magnitude condition? G of s h of s equals to 1. So what value we got the here is p equals to, we can substitute that minus 1 plus j 1.25. So substitute instead of yes, you need to substitute minus 1 plus j 1.25. So when you solve this one, so what you will get? Minus 1 plus j 1.25. If we solve that, square root of minus 1 square plus j 1.25 square, so you will get the value is 1.6. So that is the value here. And for this, the value is 2.3585. And for this, the value is 4.109. So multiply that one. Okay. So what value you will get? 1.6 into 2.3585 into 4.1907. So the value K value you will get is 15.8142. So first we will mark the zeros, that is 0, s equals to 0, s equals to minus 3, and s equals to minus 5. And next point is, that is we will mark it as a centroid point. From the centroid point we will mark the theta 1, theta 2. Okay. So you can observe the values of theta 1 equals to 60 degree. Okay, and theta 2 value is 180 degree, and the theta 3 is 300. The centroid value is minus 2.667. From here only we will mark the theta 1, theta 2, theta 3. And next wave, I said that from starting only, in the beginning only, we have found out that breakaway point will exist from between minus 3 and 0. That is the value you can observe, the breakaway point. What we got, S equals to minus 1.2137. Okay, and the p value, that is the cos inverse of zeta line intersects root locus at point p minus 1 plus j 1.25. So you can observe the breakaway point. If you mark this exists between a minus 1, so this value is minus 1 plus j 1.25 it is. Okay, so j 1.25. okay, this value is minus 1 and this value is minus j 1 point, plus j 1.25. so that is the value of p. It is intersecting both the that is theta equals to what we got. First, how you will find the p value means, first you mark from 0. Okay, mark the theta value. Okay, this is the angle 53.13. so this line and the breakaway line, once again I say how we got the minus 1 plus j 1.25. So you can observe here. So they have given that zeta value as how much they have given in the question, 0.6, right? We shall see the once again question what they have given, right? Zeta value, they have given that damping ratio 0.6. So what we need to write here, actually the triangle, if you take, this is the square root of 1 minus zeta square, 1 minus zeta square. Okay, 1 minus zeta square it will be, and this is the zeta and this is 1. So they have given the zeta value, so we want the value of theta. So theta equals to cos inverse of zeta we can take. So here they have given the damping ratio value, and from that we need to find out the theta value. So after finding the theta value, then only we can find out the value of p, that is how it will intersect with the imaginary axis. So first, after finding step 6, okay, so you have find out breakaway point. If it is angle of departure is there, you continue. If it is not there, you draw the root locus. Then you start with the theta angle. Then after marking the value of theta only, you will come to know the value of p. Okay, it intersects root locus at point p. So after drawing the overall circuit, then only overall graph you will get to know the value of p. Now first mark the value of theta from here. Okay, take compass and keep it here at 0 and mark the value of theta, that is 53.13. After marking the angle, then it is joining the breakaway point. Breakaway point is like this, it is. Okay, it is plus j 3.87 and minus j 3.87 and s equals to minus 1.312137. Okay, so after marking these two lines, so what you get here, this line and the breakaway point intersecting at this point. So this point minus 1 and the j value is plus 1.25. So that is the value of P. After finding the value of P, then you continue with the finding the angle. Okay, you need to find out the value of K and you need to find out the value of omega n. Okay, this is problem on the root locus. In next class, we shall discuss with the other problems so that you will come to know that how to find the angle of departure. Because in this there no complex roots are there, so we have not found the angle of departure. In next problems, we shall discuss with that